All right, pre-cal students. So we're going to do a few lessons here that I skipped over because I knew I didn't want to test over them, but I do want to see that. I want you to see this material. So today we're looking at graphs of reciprocal functions. We did graphs of sine, cosine, and tangent. Today we're going to look at the graphs of cosecant, secant, and cotangent. Okay? All right. So we're going to start with cosecant. Remember that cosecant is equal to cosecant x is the reciprocal of sine of x. All right, so we're going to first we're going to fill in, a table for sine. When x is 0, sine of 0 is 0. At pi 6, we have 1/2. We have root 2 over 2. Oh, I'm sorry. Pi 6 is 1/2. At pi halves, this is 1. 5 pi 6 would be 1/2. Back to 0. 7 pi 6 would be negative 1/2. Negative 1 for 3 pi halves. 11 pi 6 would be negative 1/2, and then back to 0 again. Okay? So I'm going to go on and graph that down below here using a dashed line. I'm going to connect these with a dashed line. So at 0, I'm at 0. At pi 6, I'm at 1/2. At pi halves, I'm at 1. At 5 pi 6, I'm at 1/2. Back to 0. Negative 1/2, negative 1, negative 1/2, back to 0. And I'm going to continue that pattern, so it's negative 1/2, negative 1, negative 1/2. And we're going to connect these with a dashed curve, okay? Because we're going to use this to graph cosecant, but we really are doing the graph of cosecant, not the graph of sine here. But we're going to use sine to get cosecant. Okay, so there's my graph of sine. All right, so now I do the reciprocal of each of these to get cosecant. Well, if I do 1 over 0, that's undefined. Okay, the reciprocal, if I take the reciprocal 1/2, that is 2. The reciprocal of 1 is 1. The reciprocal of 1/2 is 2. And then I am back to undefined. Reciprocal of negative 1/2 is negative 2. Negative 1, negative 2, and undefined again. All right? So, wherever my sine is 0, my cosecant is undefined. So, and I'm going to put a vertical asymptote at those places. Okay. So we're putting vertical asymptotes wherever sine is 0, because that's where our cosecant is undefined. All right. Actually, you didn't even see when I was going through this, did you? Sorry about that. If you need to pause and look at that, pause and look at that. Okay. So at pi 6, I've got a value of 2. At pi halves, I'm at 1. At 5 pi 6, I'm at 2. So this thing, as I get closer and closer to the x-axis, then my sine value gets closer and closer to 0, which means the reciprocal of that's going to go toward infinity. And so this thing, it kind of comes down like this, and then it does this. So it looks kind of like a quadratic almost, but with between two vertical asymptotes. Same thing over here. I have at negative 1, it's negative 1. At negative 1/2, it's negative 2. Negative 1/2, it's negative 2. So this is like a quadratic, a parabola that's opening down like this. And so over here, it's negative 1. When it's negative 1, it's negative 2. Here and here. Looks like that. And negative 1, negative 1, negative 2, negative 2. Okay? So those solid part, that is our graph for cosecant. It's undefined at the vertical asymptotes. In between, it goes to infinity. Notice it does not exist between negative 1 and positive 1. I mean, the range does not, I have nothing, I have things equal to positive 1 and up, or negative 1 and down, but nothing between positive 1 and negative 1. Okay? All right, moving on. Answer the following questions. The period of cosecant, all right? So how often does it repeat itself? Well, from 0 to 2 pi, it's going to be, takes one full cycle, so period is 2 pi. The maximum value, well, the maximum value is infinity. The minimum value is, it goes up to infinity, it goes down to negative infinity. The x-intercepts, it never hits the x-axis, none. Y-intercept, it doesn't hit the y-axis, none. Okay? Vertical asymptotes. All right, I've got a vertical asymptote at negative 2 pi, negative pi 0, pi, 2 pi. So x equals negative 2 pi, x equals negative pi, x equals 0, x equals pi, x equals 2 pi. In other words, multiples of pi. X equals multiples of pi. Domain, x does not equal multiples of pi, right? It is undefined at those places. All right? The range, it goes from negative infinity to negative 1, including negative 1, and it goes from positive 1 to infinity. Cosecant is this going to be even and odd? Notice that if I turn it upside down, it looks exactly the same. So this is an odd function. This is an odd function. Okay? All right. Let's do secant. So cosine, 0 is 1, pi thirds is 1/2, to 0, to negative 1/2, to negative 1. 4 pi thirds, it's negative 1/2. 3 pi halves, it's 0. 5 pi thirds is 1/2, and back to 1. So graphing that, I start at 1. Pi thirds, I'm at 1/2. 0, negative 1/2. At pi, I'm at negative 1. Negative 1/2, 0, positive 1/2, and back to 1 again. All right. Here and here. Okay. So, I'm sorry, I put all that in and I don't think you saw me do it. Okay, so here we go. So once again, I'm going to make a little dashed line here. All right, now let's come back up here. Take the reciprocal of each of these. The reciprocal of 1 is 1. The reciprocal of 1/2 is 2. Undefined at 0. Reciprocal of this is negative 2, negative 1, negative 2. Undefined again, 2 and 1. So wherever there's a 0, wherever it hits the x, where cosine hits the x-axis, secant is undefined. All right, so here. All right, and so let's do this middle part. So at 1, it's 1. At 1/2, it's 2. 1/2, it's 2. And we have what looks like a parabola between two vertical asymptotes. Same thing here, only it's opening down. So negative 1, it's negative 1. At negative 1/2, this goes to negative 2. Opens down, opens down. Here it's 2 and 1, and it comes down here, and then it's going to go back up again. At negative 1, it's negative 1, negative 2, and at 1, it's 1, 2, this is going up. Okay. So notice one full cycle goes from, it looks like negative 3 pi halves to positive pi halves, or negative pi halves to positive 3 pi halves. But again, my period is going to be 2 pi, and so we're going to have these questions on the next page here, I'm sure. Period P is equal to 2 pi. The maximum value is going up to infinity. Minimum goes down to negative infinity, so no max, no min. No x-intercepts. Let's just say none here. Y-intercept, though, I do have a y-intercept, right? It does cross at 0, 1. Okay. Vertical asymptotes. So pi halves, 3 pi halves, negative pi halves, negative 3 pi halves. Let's just do them left to right. Negative 3 pi halves, negative pi halves, positive pi halves, positive 3 pi halves. So x is equal to odd multiples of pi halves. All right. Domain, x cannot equal odd multiples of pi halves. The range is going to be, once again, from negative infinity to negative 1 inclusive, and then from positive 1 to infinity. This is an even function. If I flip it over the y-axis, it looks exactly the same. If I turn it upside down, it does not. But it folds along the y-axis perfectly. It mirrors itself over the y-axis. So this is an even function, just like cosine. Cosine is even, sine is odd. Alrighty? Okay, last one, cotangent. So this time we are taking the reciprocal of tangent. At 0, tangent is 0. At pi fourths, it's 1. At pi halves, this is going to be undefined. 3 pi fourths, it is negative 1, 0, 1, and then undefined, and then negative 1 and 0. So it's undefined at pi halves. It's undefined at 3 pi halves, because if you think about tangent as y over x, remember the x is 0 at these places. At negative pi halves, it's going to be undefined, and at negative 3 pi halves, it's undefined. Okay? And then halfway in between here, it's at negative 1, then 0, then positive 1, and it does this sort of thing. Oh, I should have made that dash, sorry. Think of this as dashed along the way. All right, that's all dashed. I'll make a dash from here on out. Sorry about that. Actually, no, we don't have to do this dash because this is for tangent. We're doing tangent here. My bad. Okay, here. And here, and here. Okay, so the reciprocal of each of these. Undefined when tangent equals 0. 1 is 1. This is going to become 0. All right, when I flip, think of this as 1 over 0. Then when I flip it, it's going to be 0 over 1, so it's 0. Negative 1, undefined. All right, 1, 0, negative 1, undefined. Okay, so this is undefined at 0, cotangent. It's undefined at pi. It's undefined at 2 pi. Alrighty, and now at pi fourths it is positive 1, at pi halves it is 0, and at 3 pi fourths it is negative 1. So this is kind of like a mirror image upside down and shifted a little bit of this one. So 0 here, positive 1, negative 1. All right, let me see, negative pi, I'm going to have an asymptote. At negative 2 pi, I'm going to have an asymptote. Sorry, I'm graphing this and you can't see it. There you go. So I'm a little off my game today, but end of the year. 0, 1, -1. There we go. So there's the, you can see tangent and cotangent right there together. All right, so let's answer some questions about cotangent. The period, so it repeats itself every pi. 0 to pi is my period. Period is pi. Maximum value, none, it's infinity. Minimum value goes down to negative infinity. X-intercepts, -3 pi halves, negative pi halves. Negative pi halves 0. Positive pi halves. 3 pi halves. Y-intercept, none. It's undefined on the y-axis. Vertical asymptotes, this would be x equals -2 pi, x equals -pi, x equals 0, x equals pi, x equals 2 pi. So x equals multiples of pi. Domain, x cannot equal multiples of pi. Range, -infinity to positive infinity. Cotangent is an odd function. If I turn this upside down, it looks exactly the same. This is an odd function. All right. So that is it. That is our lesson. Let me know if you have questions. We'll do inverse functions tomorrow.